Hi everyone, this is the first part of section 1.4. We're going to start by talking about increasing, decreasing, and constant functions. So first let's take the case when a function f is increasing. We say that a function f is increasing if, first of all, when you look at the graph and when you look at the graph from left to right, there is an upward trend, right? Where the y values are eventually getting higher and higher. More formally, we say, as you move along to respective values of x, their y values will get higher and higher and higher. So that's a function that's increasing. And normally we denote an interval over which a function is increasing. So we say, for example, this function is increasing from negative to positive infinity. Those are the x values. Or I can say this function is increasing from x1 to x2. They're the x values. A decreasing function is when, as you move towards consecutive x values, the y values are getting lower and lower and lower. And if you look at the graph, you can visually see that there's a downward trend. A function is constant if moving from one x value to consecutive x values, the y values stay the same. So that's a constant function. All right, so let's take a look here. Consider the following graph and determine the intervals on which the function is increasing, decreasing, or constant. Okay, so let's just take a look at the graph here. You can see here that this graph is increasing until about here, right? Until about here. X equals -3. Then it starts to decrease until here. X is +2. Then it starts to increase again until about 6. And then the graph is constant from 6 on out. Okay, so what we do is we're going to write down the intervals where the graph increases, decreases, and is constant. Okay. So let's first look at the first part, right? In this region, when the graph is increasing, it starts to increase from negative infinity, right? From the x's. So remember, these are only the x values. It starts increasing from negative infinity to about x equals -3. So we say negative infinity to about -3, close that interval. And then it starts increasing a second time from 2 to 6, right? From 2 to 6. Now, notice both 2 and 6 have open circles, so I have to put open parentheses. Okay, so where does the graph decrease? The graph decreases here from x equals -3 to x equals 2, -3 to 2. It includes -3, but it's open at 2 because there is an open circle at 2. And then where is it constant? It's constant starting at x equals 6, moving on out. So starting at x equals 6, moving on out, it does include 6, so I put a bracket. Infinity always gets parentheses. Here's my question for you. Did I ever look at y values? And was I ever concerned with, oh, it goes up to y equals 2, y equals -7? No, because these intervals are only for x values. All right, moving along. Use the graph of the function to estimate the intervals to the nearest 0.5 unit on which the function is increasing, decreasing, or constant. Support your graphs using a calculator, a graphing calculator, and I'll talk about that part in a minute. Let's take a look at this first one, 2x cubed. You see how it's increasing the whole time, right? But now, you might tell me, but Mrs. Malikian, there is a point here where it's constant. Well, let's think about that. Is it really constant? Well, let's think about it, just by reasoning through it, right? What is the function for this? 2x cubed. Is there ever an opportunity where you plug in increasing values of x and the y values don't change? They stay the same? No. So whether, you plug in, x equals negative 0.1, negative 0.01, or 0, or 0.1, or 0.2, right? As the x values get larger, the y values, because it's 2 times x cubed, are also going to get larger. So this function is, in fact, increasing on its entire domain from negative to positive infinity. All right, so now let's go ahead and support using a graphing calculator. On my graphing calculator here, I've graphed 2x cubed, right? Let's go to menu, and this time I want to trace, graph trace, right? And let's start, down here. Okay. All right. So as I'm going to trace this graph, take a look at the y values and take a look if they're increasing, decreasing, or constant. So you see how the y values are getting bigger and bigger and bigger, right? Every single time. That's another way that you can support graphically with a graphing calculator that it's increasing and decreasing. Okay. Important note. For my homework, you don't have to do the graphing calculator part. I just want you to be able to look at the graph and come up with the intervals where it's increasing and decreasing. Okay, here. The graph decreases until x equals 2. So we say it decreases from negative infinity to 2. And then it increases from 2 to positive infinity. And somebody might be saying, well, what about at x equals 2? Is it increasing or decreasing? You could make the argument that it's not doing anything, but that's irrelevant because by definition, functions increase and decrease not at individual points, but on intervals. So it's actually meaningless to say at x equals 2 is something increasing or decreasing because you have to compare it to another point. Okay. Let's talk about this one. We have a region where it's increasing here and then it's increasing there. So we say the graph increases from negative infinity to 0, and these are both open because of that open circle, and then it picks up again at x equals 3 to infinity. And then this graph is constant from 0 to 3. And it's not decreasing anywhere. All right, what about this one? It's increasing here, then decreasing, then increasing again. And the points where it changes are negative and positive 1. So we say the graph increases from negative infinity to 1, from 1 to infinity, and then it decreases from negative 1 to positive 1. Okay. Let's talk about relative and absolute extrema. I'm actually going to come back here for a minute. You see what happens here to this graph? This graph was increasing, and then at this point, it changed from increasing to decreasing. At that point where a change happens from increasing to decreasing, we say the graph has a maximum. And take a look here. The graph was decreasing, and then at this point it changed to increasing. So we say at that point the graph has a minimum. Visually, they look like peaks and valleys. So let's look more closely at what these are, okay? A relative maximum is a point where the graph, like I said, changes from increasing to decreasing, all right? Now, if that point, so right here, this is a relative maximum, this is also a maximum, but take a look at this point specifically. That is the absolute highest y value that the graph reaches. We call that the absolute maximum. The graph cannot possibly go any higher, right? So relative maximum is basically any maximum within a specific region. An absolute maximum is the very, very highest a graph can reach. All right, relative minimum. A relative minimum is a location where the graph changes from decreasing to increasing. So there is a relative minimum here, okay? There is another minimum here. Because this is the absolute lowest point that the graph can reach, we call this an absolute minimum. Okay, so so now you're asking, okay, so if I have a minimum, how do I know? If you ask for relative min or max, what do I say? Well, here it is. It's really another moot point because in real life, we never really look at the entire function at once. We only look at certain intervals, like from x equals -3 to 2, you know, where are the minima and the maxima and so on. So here's what I want us to do here. Estimate and classify the local and absolute extrema. Now here's another word, local. That's another word for relative. Okay, so here's what we need to do. Let's agree on this. Anything except for absolute max or min will be called relative or local max or min. When I say extrema, that word is an umbrella word for minimum and maximum. So here basically we need to find all of the minima and the maxima. Okay, so take a look here. There is a maximum here. Okay, now, is that an absolute maximum? No, it's not, because look, the graph goes higher on both of these ends, right? So that's just a relative maximum. Okay, and how are we going to say what point that is? That is the point 0, 3. And the way I want you to say it is f of 0 is equal to 3 in function notation. All right. Okay, well, what about minima? I have a minimum here and a minimum here. Now, both of those are absolute minima. So I say, okay, we have absolute minima at -1, -1, and then 1, -1. But we're going to write it as f of -1 equals -1, f of 1 equals -1. Okay. All right. Take a look here. Let's identify the extrema for these ones. All right, so you can see here there is a minimum right here, and that is the absolute minimum. So I say, okay, absolute minimum is f of -3 equals -4. Okay, a little bit of notation. When you're asked to find extrema, this is how you write it. Now, sometimes you might be just asked for the location, and that's the x value, or you might be just asked for the value, and that is the y value. Okay, so just a little bit of stuff there. Okay, let's take a look here. I have maximum here, and that's it, right? Okay, so Are any of these absolute maxima? No, because look, the graph goes much higher over there. But I do say, okay, there are maxima at the following points. One is f of -1 is equal to 2. Okay, before you ask, well, why didn't you write relative min or max? Because you actually don't have to. Once we normally just specify absolute max or min, and then for the relative, it's enough to just say max or min. Okay, what about that one? That one we have to do using a calculator. So what we're going to do is plug it into the calculator, right? We're going to plug that function into the calculator and find that value. Okay, so I do have that function graphed here. And what we're going to do is we're going to find the maximum value there. So we're going to do menu, analyze graph, and look, this one maximum, right? So we go before the point, after the point, and that's the point right here. It's always a good idea to kind of move the point up or down because sometimes there is a negative, right? We saw that before that coincides with the x-axis and you can't see it. Okay, so we say there is another maximum at, it's f of 0.659 equal to 0.478. Okay, let's go to 3 decimal places. Okay, minima. There is a minimum here, and that's f of 0 is equal to 0. And then there is another minimum here, and if you use the calculator to find it, it's f of 1.899 equal to -4.191. Okay, that's where we're going to end today. You can go ahead and start on your homework. Thank you.